Hello friends, welcome to our channel Mechanical Motivator. In this video, we'll be seeing Klien construction. There are two types of method. One will be analytical method and second one is the graphical method. In analytical method, we solve many problem and we have determined the velocity and acceleration of piston and angular velocity and angular acceleration of connecting rod. In this, we're going to determine the same thing, but with the help of graphical method. So there are many methods like relative velocity, relative acceleration method, instantaneous center method. So all these method we have already studied in kinematics of machinery. In this semester, that is in dynamics of machinery, we'll be seeing new three methods. That is Klien construction method, Ritterhaus construction method, Bennett construction method. In this video, we'll be seeing Klien construction method and we'll be determining the velocity and acceleration of piston, angular velocity and angular acceleration of the connecting rod. For solving that, we are having 5 different steps. So first step is construction of configuration diagram. We need to construct the diagram with the help of the given data like crank radius, crank angle and connecting rod length. Second step is construction of Klien velocity diagram. So second step, this is very important and we need to mark the Klien velocity diagram. And third step is determination of velocity of various length using Klien velocity diagram. So for third step is we need to determine the velocity for various length using Klien velocity diagram. And fourth step is construction of Klien acceleration diagram. Fifth step is determination of acceleration of various length using Klien acceleration diagram. So if you follow step by step, it's very easy for us to calculate. Now we'll be seeing a basic problem and it's very easy too. The crank and the connecting rod. Crank and the connecting rod of reciprocating engine are 200 mm and 700 mm respectively. So crank is OC is the crank. So OC is equal to 200 mm and connecting rod is PC. So PC is equal to 700 mm. The crank is rotating in a clockwise direction. So just note down clockwise direction. At 120 radian per second. So omega is equal to 120 radian per second. Find with the help of the Klien construction. Velocity and acceleration of the piston. So velocity and acceleration of piston. Velocity and acceleration of midpoint of the connecting rod. Angular velocity and angular acceleration of the connecting rod at the instant when the crank is 30 degree to inner dead center. So they are clearly given the crank angle, crank radius and connecting rod length. So now we are going to plot the diagram. For that, we will be using some scaling. That is, there are 3 types of scaling. One is enlarged scale, second is exact scale, third is reduced scale. Enlarged scale is if you are having a smaller value means it's very difficult to plot. So what we do, we will be using we'll be multiplying with some factor and plotting it. So it's enlargement scale. Exact scale means we'll be using the same value whatever they are given in the problem and plotting in our diagram. And third is reduced scale. In our problem, we are going to use only reduced scale. The reason is 700 mm, that is 70 centimeter is a very huge value. We can't draw in our A4 sheet. So for that, we will be going for a reduced scale. Fixing the scale is R1 wedge. In this problem, I have taken as 1 centimeter as 50 mm. So 1 centimeter is equal to 50 mm. So whatever values you are having, just divide by 50. And finally, whatever answer you get, just multiply into 50 for getting into in terms of millimeter. So first step, what is the first step? We need to construct the configuration diagram. So we are having the crank angle, we have crank radius and we have connecting rod length. So the crank radius is 200 mm. So 200 mm means if you divide it by 50 means you will be having 4 centimeter. So first what you do, just draw a straight line and in that straight line place a point O. Anywhere you can keep, place a point O. Now you have the angle 30 degree and crank radius is 4 centimeter. I am just divided 200 mm by 50. So you're having 4 centimeter. For 4 centimeter, draw a line and have the crank angle as 30 degree. For 30 degree with 4 centimeter, draw a line and you will be getting a point C. Fix it there. Next is connecting rod length. So 700 mm. So 700 divided by 50, you will be having 14 centimeter. So place the compass at point C. Just cut an arc at this straight line for 14 centimeter. You will be getting the point P. So you have got P, C, and O. So this is the configuration diagram. I hope it's so. I hope so. It's very clear. Now we will be going for the second step. Second step is construction of Klien's velocity diagram. We're going to construct Klien velocity diagram. So don't get messed up with this. It's very easy. Just follow as I say. Now what you're going to do? Just draw a line perpendicular to point O. To point O, just draw a line perpendicular to point O to some certain distance. Then to try to extend the connecting rod length to certain distance so that these two lines meet or intersect. So you will be getting an intersection point. I mean, keep that point as M, capital M. You're going to draw a straight line perpendicular to O to certain distance, and then you're going to extend the connecting rod to certain distance so that these two lines meet at a particular point, and that point is called M. The triangle OCM is called as the velocity diagram, Klien's velocity diagram. We have constructed Klien velocity diagram. So OCM is called as Klien velocity diagram. Next, what we're going to do is just the connecting rod length, right? So C to P. No, actually don't go there. We need to do one more step, that is C to M. That is C. You got here, right? C to M. You will be having certain distance. Take a midpoint between C to M. So C to M, take a midpoint and keep it as D1, as well as in connecting rod you keep a midpoint and write as D. Next, what you're going to do is take the radius as CM. So just take your compass and your radius is C to M is your radius. Draw a circle with center C. So place your compass at C and CM as radius, draw a circle. Next, place your compass at point D and CD is your radius. CD or DP, anything is okay. So CD is your radius. Place your point at the center D, place your compass at center D and draw another circle, big circle you'll be getting. These two circles will be intersecting at two different points. First point will be here and second point will be here, and just write that point as K and this point as L. So right now it's clear, I think so. So you have got K and L. Next, what you're going to do is, next step is try to join K to L. So you got two different points, right? Here K, here L. So just to draw a straight line. Just join these 2 points. Just to join K and L. So we'll be joining K and L and try to extend that point till it meets the line of stroke. So till it meets the straight line or line of stroke. So K, L, N. So these 3 points will be in a same collinear points in the same line. Join K and L and extend that line so that it meets at the line of stroke and place that point as N. Now you will be getting a parallelogram diagram, that is OCQNO. This is just like a parallelogram. So just have a mark with this. We will be using in our problem. So your first thing is you got first triangle. OCM is your triangle. That is the Klien velocity diagram. And now you got OCQNO. It's a parallelogram. So just have a mark of it. Will be it will be useful for solving the problem. Next step is actually the extra. I mean, they actually did some extra work, but no need to worry. I think so. It's very clear till this point. We'll be going into the problem and we'll be solved step by step. So first thing is Klien velocity diagram is OCM. So OCM is the Klien velocity diagram, and Klien acceleration diagram. That is Klien acceleration diagram is CQNO. So Klien acceleration diagram is CQNO is the Klien's acceleration diagram. So we have drawn with that some suitable scale, and once you measure OM, you will be getting some value. Just be clear, you will be measuring OM, you will be getting some answer, and just multiply that answer with 50, you will be getting 127 millimeter. Okay, try to understand. Measure OM, you will be getting some answer, multiply with 50 because we have scaled right. multiply with 50, you will be getting 127 mm and you convert into meter. Next is cm. Just measure cm, whatever value you are getting, multiply with 50, you will be getting 173 mm and convert to meter. Next is qn. Just measure qn, you will be getting some value, multiply into 50, you will be getting 93 millimeter and convert into meter. Next is NO. Measure NO and multiply with 50. You will be getting 200. You will be getting 200 mm and convert into meter. So now we got all the values. It's very easy for solving the problem. First question, what they asked us, we need to calculate the velocity and acceleration of the piston. Velocity and acceleration of piston. We know that velocity of the piston P is velocity of piston P is Vp is equal to omega into Om. So omega value we know. Omega we already they have given in the question. Omega value 120. Omega into Om. Om value we just now got 0.127 meter. So 120 into 0.127 meter, you will be getting the value as it is. Next is acceleration of the piston. So AP is the acceleration of the piston. Formula is omega square into NO. So omega square into NO. NO we have already calculated 0.2. So just multiply and you will be getting the value. We have obtained the velocity and acceleration of the piston. So first question we have found it. So second is velocity and acceleration on the midpoint of the connecting rod. So this is the midpoint of the connecting rod. We need to determine the velocity and acceleration at this point. In order to find the velocity and velocity of the midpoint D of the connecting rod, divide CM at D1. We have already did. We have divided CM. We have already divided CM. Center is D1, and also we divided CP and center is D. In the same ratio as D divides CP. Okay. So actually we these things we have already done, since D is the midpoint of CP. So that's these things we have already done. Thing is we need to measure OD1. That's it. So measure OD1. So where is O? Yeah. Join this D1 with O. Join this D1 with O and measure OD1 value. Whatever value you are getting, just multiply into 50. So you will be getting some value 140 millimeter. It's converted into meter. So velocity of D. So velocity of D in Klien velocity diagram, we will be getting the answer. In Klien velocity diagram, velocity of D BD is equal to omega into OD1. OD1 we got. So omega value we know. So we will be getting 16.8 meter per second. In order to find the acceleration of the midpoint of connecting rod, draw a line joining D2 parallel to the line of stroke PO which intersects CN at D2. Just nothing but draw a line. Now till this you will be understood. Now just have a look at this. Draw a line parallel to the line of stroke. Draw a line parallel to the line of stroke so that it meets the KN at certain point. So if you're drawing a line, means it will be meeting K to N at certain point. You fix that point as D2. Try to understand more. Draw a line parallel to the line of stroke. It will be intersecting at this point, and that point is called as D2. And join OD2. Join OD2 and measure the OD2 value and multiply with 50. You will be getting measure OD2 and if you measure in the diagram, you will be getting some value, and if you multiply with 50, you will be getting some value, and that value is 193 millimeter. So convert into meter. Acceleration of D is nothing but AD. Acceleration of D is nothing but omega square into OD2. So omega we know and OD2 just now we measured, and you will be getting the answer. And third thing is angular velocity and angular acceleration of the connecting rod. So coming back, so velocity of the angular velocity of the connecting rod, that means velocity of P with respect to C we already got. So velocity of PC is nothing but omega into Cm. So angular velocity of the connecting rod we just going to determine. So it's nothing but omega into Cm. So Cm already we calculated. Cm is distance. C to M already we measured and we have wrote here. So omega into Cm, that is nothing but 120 into 0.173, you will be getting some answer. So this is the velocity of the connecting rod. Now it's actually a small mistake. It's angular velocity of the connecting rod, not angular acceleration. It's angular velocity of the connecting rod PC. So omega PC is nothing but velocity of the connecting rod divided by PC. So velocity, we got the value. So velocity of connecting rod, we got the value. So just divide that value with the connecting rod length. Connecting rod is 700 millimeter. So connecting rod length is 700 millimeter, 0.7 meter. So that's what they did. They have just divided the velocity of connecting rod with the distance of the connecting rod. So you'll be getting the value. The next thing is, we know that tangential component of acceleration of P with respect to C, that is nothing but Qn. So see here, Qn. Even you can see here, Qn is the tangential acceleration of connecting rod with respect to P and C. That is, this is the tangential acceleration of the connecting rod, Qn, or else you can also see in this item Q to N, Q to N. So what they are doing is, tangential component of acceleration of P is Qn. So ATPC, that is a tangential component of acceleration, is equal to omega square into Qn. Qn value we already noted. Qn we already measured and wrote. So just multiply that value, you will be getting some value. Angular acceleration of connecting rod. Angular acceleration of connecting rod is represented as alpha PC. So it is a ratio of tangential component to connecting rod length. So tangential component of acceleration divided by connecting rod length. So tangential component we just now got divided by the connecting rod length. So you'll be finally getting this value. So right now we have determined all the values, that is velocity and acceleration of piston and angular velocity and angular acceleration of connecting rod we have determined. So it's a very easy method. So don't get confused with this diagram. It's very easy. If you see step by step and if you graphically draw and see, you can easily get the value. It's a mark scoring also. In case if you are having any doubt in this construction means, just type in the comment section so that I will help you. Please do subscribe to my channel Mechanical Motivator and press the bell icon. Then only you will be getting all the videos which I upload. Thanks for watching this video. Have a great day.